In mathematics, a classification theorem answers the classification problem: what are the objects of a given type, up to some equivalence. It gives a non-redundant enumeration. Each object is equivalent to exactly one class. A few related issues to classification are the following. The equivalence problem is, given two objects, determine if they are equivalent. A complete set of invariants, together with which invariants are realizable, solves the classification problem, and is often a step in solving it. A computable complete set of invariants solves both the classification problem and the equivalence problem. A canonical form solves the classification problem, and is more data. It not only classifies every class but gives a distinguished element of each class. There exist many classification theorems in mathematics, as described below. Geometry. Classification of Euclidean plane isometries. Classification theorem of surfaces. Classification of two-dimensional closed manifolds. Enrique's code error. Classification of algebraic surfaces. Nielsen-Thurston classification, which characterizes homeomorphisms of a compact surface. Thurston's 8 model geometries, and the geometrization conjecture. Algebra. Classification of finite simple groups. Artin-Wedderburn theorem, a classification theorem for semi-simple rings. Linear algebra. Finite-dimensional vector spaces. Rank nullity theorem. Structural theorem for finitely generated modules over a principal ideal domain. Jordan normal form. Sylvester's law of inertia. Complex analysis. Classification of Fatou components.